What is a function? The natural world is full of relationships between quantities that change. When we see these relationships, it is natural for us to ask, if I know one quantity, can I then determine the other? This establishes the idea of an input quantity or independent variable and a corresponding output quantity or dependent variable. From this, we get the notion of a functional relationship in which the output can be determined from the input. For some quantities, like height and age, there are certainly relationships between these quantities. Given a specific person and any age, it is easy enough to determine their height. But if we try to reverse that relationship and determine age from a given height, that would be problematic, since most people maintain the same height for many years. Function. A rule for relationship between an input or independent quantity and an output or dependent quantity in which each input value uniquely determines one output value. We say the output is a function of the input. Example 1. In the height and age example above, is height a function of age? Is age a function of height? In the height and age example above, it would be correct to say that height is a function of age, since each age uniquely determines a height. For example, on my 18th birthday, I had exactly one height of 69 inches. However, age is not a function of height, since one height input might correspond with more than one output age. For example, for an input height of 70 inches, there is more than one output of age, since I was 70 inches at the age of 20 and 21. Example 2. At a coffee shop, the menu consists of items and their prices. Is price a function of the item? Is the item a function of the price? We could say that price is a function of the item, since each input of an item has one output of a price corresponding to it. We could not say that item is a function of price, since two items might have the same price. Example 3. In many classes, the overall percentage you earn in the course corresponds to a decimal grade point. Is decimal grade a function of percentage? Is percentage a function of decimal grade? For any percentage earned, there would be a decimal grade associated, so we could say that the decimal grade is a function of percentage. That is, if you input the percentage, your output would be a decimal grade. Percentage may or may not be a function of decimal grade, depending upon the teacher's grading scheme. With some grading systems, there are a range of percentages that correspond to the same decimal grade. One-to-one function. Sometimes in a relationship, each input corresponds to exactly one output, and every output corresponds to exactly one input. We call this kind of relationship a one-to-one function. From example 3, if each unique percentage corresponds to one unique decimal grade, each unique decimal grade point corresponds to one unique percentage, then it is a one-to-one function. Function notation. To simplify writing out expressions and equations involving functions, a simplified notation is often used. We also use descriptive variables to help us remember the meaning of the quantities in the problem. Rather than write, height is a function of age, we could use the descriptive variable h to represent height, and we could use the descriptive variable a to represent age. Height is a function of age if we name the function f we write. H is f of a, or more simply, h equals f of a, we could instead name the function h and write h of a, which is read h of a. Remember, we can use any variable to name the function. The notation h of a shows us that h depends on a. The value a must be put into the function h to get a result. Be careful. The parentheses indicate that age is input into the function. Note, do not confuse these parentheses with multiplication. Function notation. The notation output equals f input defines a function named f. This would be read, output is f of input. Example 4. Introduce function notation to represent a function that takes as input the name of a month and gives as output the number of days in that month. The number of days in a month is a function of the name of the month, so if we name the function f, we could write days equals f of month or d equals f of m. If we simply name the function d, we could write d of m. For example, d of March equals 31 since March has 31 days. The notation d of m reminds us that the number of days, d of the output, is dependent on the name of the month, m of the input. Example 5. A function n equals f of y gives the number of police officers in a town in a year y. What does f of 2005 and 300 tell us? When we read f of 2005 equals 300, we see the input quantity is 2005, which is the value for the input quantity of the function, the year y. The output value is 300. The number of police officers in, a value for the output quantity. Remember, n equals f of y. This tells us that in the year 2005, there were 300 police officers in the town. Tables as functions. Functions can be represented in many ways. Words, as we did in the last few examples, tables of values, graphs, or formulas. Represented as a table, we are presented with a list of input and output values. In some cases, these values represent everything we know about the relationship, while in other cases, the table is simply providing us a few select values from a more complete relationship. Table 1. This table represents the input number of the month. January equals 1, February equals 2, and so on, while the output is the number of days in that month. This represents everything we know about the months and days for a given year that is not a leap year. Table 2. The table below defines a function q equals g of n. Remember, this notation tells us g is the name of the function that takes the input n and gives the output q. Table 3. This table represents the age of children in years and their corresponding heights. This represents just some of the data available for height and ages of children. Example 6. Which of these tables define a function, if any? Are any of them one-to-one? The first and second tables define functions. In both, each input corresponds to exactly one output. The third table does not define a function since the input value of 5 corresponds with 2 different output values. Only the first table is one-to-one. It is both a function and each output corresponds to exactly one input. Although table 2 is a function, because each input corresponds to exactly one output, Each output does not correspond to exactly one input, so this function is not one-to-one. Table 3 is not even a function, so we don't even need to consider if it is a one-to-one function. Solving and evaluating functions. When we work with functions, there are two typical things we do: evaluate and solve. Evaluating a function is what we do when we know an input and use the function to determine the corresponding output. Evaluating will always produce one result, since each input of a function corresponds to exactly one output. Solving equations involving a function is what we do when we know an output and use the function to determine the inputs that would produce that output. Solving a function could produce more than one solution, since different inputs can produce the same output. Example 7. Using the table shown, where Q equals G of n, A, evaluate G of 3. Evaluating G of 3, read G of 3, means that we need to determine the output value, Q, of a function G given the input value of n equals 3. Looking at the table, we see the output corresponding to n equals 3 is Q equals 7, allowing us to conclude G of 3 equals 7. B. Solve G of n equals 6. Solving G of n equals 6 means we need to determine what input values, n, produce an output value of 6. Looking at the table, we see there are two solutions, n equals 2 and n equals 4. When we input 2 into the function g, our output is q equals 6. When we input 4 into the function g, our output is also q equals 6. Graphs as functions. Oftentimes, a graph of a relationship can be used to define a function. By convention, graphs are typically created with the input quantity along the horizontal axis and the output quantity along the vertical. The most common graph has y on the vertical axis and x on the horizontal axis. And we say y is a function of x, or y equals f of x, when the function is named f. Example 8. Which of these graphs defines a function y equals f of x? Which of these graphs defines a one-to-one function? Looking at the three graphs above, the first two define a function y equals f of x. Since for each input value along the horizontal axis, there is exactly one output value corresponding, determined by the y value of the graph. The third graph does not define a function y equals f of x, since some input values, such as x equals 2, correspond with more than one output value. Graph 1 is not a one-to-one function. For example, the output value 3 has two corresponding input values, -1 and 2.3. Graph 2 is a one-to-one function. Each input corresponds to exactly one output, and every output corresponds to exactly one input. Graph 3 is not even a function, so there is no reason to even check to see if it is a one-to-one function.